So now we're going to talk about our population word problems. So we just talked about our financial word problems. Now we're going to talk about population. So this formula should look very familiar because this is the exact formula as PERT. Remember when we did PERT, P-E to the R-T? It's just that the P changed to an I. It's the same thing. P in the last formula meant what did I start with? A was what did I end with? Same thing. It's just population. So what did we start with the population? What did we end with the population? R is rate, T is time. This formula I'm going to talk about when we get to that problem, but for now I'm not going to worry about this problem. Okay, so number 1 says the population of ants was 1,000, but after 1 day we had 1,500 ants. How many ants will there be in 2 days? How many ants will there be, or how long will it take for there to be 10,000 ants? So if we read this problem, what should be jumping out in your head is, they didn't tell me the rate, right? How fast is this population growing? I don't know the rate. Is it 5%? Is it 2%? Is it 10%? That's important. I can't really answer these questions unless I know the rate. So that's exactly what we're going to do first. Step 1 of our problem is I have to find the rate. So we're going to use this first sentence here to help us find the rate. So it's telling us we started with 1,000. After 1 day we had 1,500. So I'm starting with 1,000. After 1 day I had 1,500. E to the rate I don't know, but I know my time was 1 day. So now we're going to use our algebra skills to solve. So we're going to divide by 1,000. We get 1.5 equals e to the r, because r times 1 is just r. Now I need to use logs, so log base e, so ln of 1.5 equals r. So ln of 1.5 tells us our rate is 0.405. So that means our rate is like 41%. That's actually a really big rate. So it's growing by 41%, almost double each day. That's a lot. Okay, so we're going to have to use this number, so make sure you store that. So I'm going to store it as A. So now we need to figure out how many ants will there be in 2 days. That's what we're going to figure out next. It's how many ants will there be in 2 days. So in 2 days, I don't know how many I'm going to have, but I know we're starting with 1,000. I know the rate now I stored as A, and I know the time is 2 days. That's what this is what I'm trying to figure out. How many do I now have? So let's go ahead and plug that into our calculators. 1,000 e to the A times 2, right? Because we stored the rate as A. So we're going to have 2,250 ants in 2 days. That's a lot of ants. Okay, now the second question is asking how long until we have 10,000 ants. What's the time of that? So I want there to be 10,000 ants. I started with 1,000. The rate is A, and I don't know the time. So we have to use our algebra skills, divide by 1,000. We get 10 equals e to the AT. Change it to log base e of 10, so ln of 10 is equal to AT. To get time by itself, we got to divide by A. So ln of 10. Make sure you end your parenthesis, divided by our stored value of A, we get 5.679 days. So it's going to take almost 6 days for there to be 10,000 ants. That's crazy. All right, so in number 2 here, we're talking about half-life. So what it's saying is that half-life of rhenium is 690 years. So it's saying that it's going to take 690 years to have half of it left. So it's saying we're starting with 60. It's going to take 690 years, and then I'm only going to have half of it left. I'm only going to have 30 left. So it's going down, but it's going to take that many years for it to go down to half. I want to know how much is present by 490 years. So, once again, the big piece of information that's missing is the rate. I can't answer this question until I know what the rate is. So I'm going to have to use this information to help me figure that out. So I start with 60. After 690 years, I have 30. I don't know the rate. So I started with 60. I have 30 now after this many years. Divide by 60. We get 0.5 equals e to 1690r. Change it to log, so ln of 0.5 equals 1690r. Divide. So when you do that, notice here that this is e to the negative 4, which means really there you have to move the decimal 4 whole times, right? So that's like a really, really, really small rate. This is like saying negative 0.000410. That's really, really, really small. So we're going to make sure we store this. It's A. Now we're going to answer this question. So if I have 60 now, how many will I have after 490 years? That's what it's asking. Ask yourself, is it going to be more than 30 or less than 30? Well, if it takes 1,690 years for it to get to 30, this isn't anywhere close to that number of years. So we're still going to be somewhere between 60 and 30, right? Our answer is going to be somewhere between 60 and 30. So 60e to the a times 490 gives us 49.076 grams. Okay, a colony of bacteria increases according to the law of uninhibited growth. If the number of bacteria doubles in 5 hours, represent the function for this growth. So if we start with I, I'm going to have double the amount in 5 hours. Don't know the rate. So that's our function. B, if there are 10,000 cells initially, how long will it take for it to get to 25,000? So if I want to know this answer, I better know the rate first. So I'm going to have to use this to help me find the rate. So our first step is divide by I. So I get 2 equals e to the 5r. Change to ln. ln of 2 equals 5r. Divide by 5. Store that. If there are 10,000 initially, rate is A. How long will it take for there to be 25,000? So I'm going to let you guys solve this problem. Go ahead and pause, solve, and then unpause and see if you got it right.